Welcome to another episode of Inside F1. Today, General Manager Julien Salles is joined by CEO Raphaël Salles as well as two key members of our R&D team, Production Engineer Raphaël Gérard, otherwise known as Doc, and Charles Bertrand, Naval Architect. In this episode, the team shares insights into how F1's R&D process works, the secrets behind the dynamic structural design, and how it all shapes the performance of our gear. They also dive into the latest innovations, including the SK8 and MOMENTUM foils, offering a closer look at what makes these products stand out. Join us for an engaging conversation that breaks down the engineering and design choices driving F1's approach to foil performance.
Welcome back, everyone. Hope you're well, hope you're excited. Tonight we're talking about foils. It's going to be interesting because we're going to tell you a bit about the background of how we develop the product and more details on the features and everything. You know most of the people that are here tonight, but maybe we will introduce ourselves again. So we have a lot of foil geeks out here. And let's start maybe with the big boss and F1's president, Raphaël. Who are you, Raphaël?
I'm Julian's father.
Yeah, that's it.
And I have to go to the beach every day testing products.
It's a tough life.
Really tough life those days because we have a lot to test.
Charles, let us know a little bit about who you are, your background, how long you've been working with F1 and what you are doing here.
Sure. So I'm Charles. I'm a naval architect and I've joined F1 in 2012, so quite a few years back. And I've been designing all the boards and all the foils for F1 since then. And we built the whole foil program from scratch, from the beginning all together. And now I'm focusing on the shapes. So I'm responsible for the shapes of the boards, the foil boards that we see here around us, and the foils as well. And I'm working a lot with Doc. It's a teamwork. What do you do, Doc?
What I do? I don't know, actually. Now, I'm a composite engineer, so I deal pretty much everything that is structural and around composite. So composite is a mix of resin and fiber. So it's a bit of a specific materials because there's so fibers involved, so you need to work along the fibers, so it's a bit more complicated than a normal steel or plastic. But it's actually pretty exciting and pretty cool to work with. I've been with F1 for 4 years, and I was a consultant in the composite industry before, designing other things, boats like Charles before, and race cars and stuff like that, so that was cool. And then I took the opportunity to come here and have a very exciting job.
Okay, guys. My name is Julien. I am your podcast host for this week, and I will be asking questions to these guys tonight. So, guys, I have a question for you, and maybe you can explain to the viewers, how does F1 make foil? And like from the idea to the production, how does it work? Like, for example, let's say we want to make a new surf foil. How do you guys begin?
Well, we're now lucky enough that we have enough background to rely. We have quite a library of things we've done before, shapes, constructions. And so the first thing, obviously, where we start with, we have a design brief. Like, I want this foil to do this and to do that. And I don't want this foil to do this or to do that. And so, we start, building the portrait of the foil, like, what sort of size, what sort of aspect ratio, what sort of
low end, high
end, exactly. The main features, the main behavior that you expect on the water they're translated into the main parameters. Like,
let's say if I want glide, you're gonna think
you're gonna put more aspect ratio, things like this, and then we start with a profile that we know, and we make a first shape together with the first construction. And then, so we usually start working on the shape first, and then we refine on the construction in the second stage, which is just as important. And
we are lucky enough to have a facility to prototype stuff. So we have, you have invested into a room where I basically spend half my days alone in the garage, and where we have a CNC machine to make the molds. So once we've decided a potential candidate for that new surf foil that you're talking about. Charles has designed a 3D shape. Then we make a mold out of that. We cut the mold out of a big plank of material and then laminate some fibers in it. Press it together, and then we have a foil that is ready to go. So we work together with Matt. Basically laminate the foil. Once it's finished, we go on the water. We test it against the database, as Charles has mentioned. So we test it against the database that we have, and we basically evaluate the different parameters that we want to either increase or are they acceptable or not. So glide, speed, maneuverability, etc. And then we iterate on top of that.
So we do that process a lot, I guess, like redesigning, remaking protos, retesting, blah, blah, blah. Once we have the good foil on a prototype, what happens?
So once we have a shape, because the thing is we don't want to mess up the hydrodynamic parameters of the foil with different constructions. So it's always the same construction at first. So we have kind of a database also with is it a very high aspect ratio or is it a mid aspect, for example, something like that. So we have a laminate or construction for this type of just overall family. And then so we don't want to play with the construction first. So once we are happy with the shape, then we can start on playing with the constructions. So we order the mold at the factory. And then basically, this is what we call the DSD, that I'll talk about a bit later, is playing with the different fibers and orientation, materials to basically achieve something that we like. When we order the mold at the factory, we order samples as well. And there's usually 4 or 5 different constructions. So we can receive all together and then test it against each other.
You're kind of playing a blind test with the testers, but maybe we will talk about that during the DSD parts of the presentation. Then basically we select the right layup, we select the right shape, then we select the right layup, and then it goes into production.
Exactly.
So for you that are watching, Charles is more in charge of the shape of the product, and Doc is more in charge of the structural design of the product. And which one is more important?
I think
it's equally as important, especially with the foils, because we evaluate into a medium that is very dense. The water is very dense. If you compare to a plane, for example, which is the same, a foil and plane is roughly the same characteristics, but we play in a very different fluid, and it's 1,000 more dense the water than the air. So there is stuff that happens to the structure of the foil that you can't, just put your hands like this and say, oh, I don't see it. you need to go and really understand what's going on with the shape of the foil and what's going on when it's loaded, so you don't have bad effects on the behavior of the shape itself. If for example, I make a foil that is a complete noodle, then when you'll go in the water, it will deform so much. Then actually what Charles has designed, the perfect, nice page and then 3D, then it will be completely messed up. That's why it's really important to basically work alongside, because if he's done something that is not working hydrodynamically, it won't work. But if I'm not doing something that is structurally sound, it won't work either.
Yeah, especially now we have the demand for the performance of the foils has obviously increased as every generation of foil, the demand gets more, it's higher, and so we're driven towards sections that are smaller. So it's always like where we were doing the Phantoms some years back, it was easy to make construction that was stiff enough. We have more leverage and enough to play around. Now, every time I'm trying to push the envelope, then it's going to affect structurally the foil. So it's always a trade-off now. Like when you push one slider on one side, it's changing the slider on the other side. So you really have to trade carefully and make the right choices. So yeah, it's getting very Both disciplines are very intricate.
I think so. I mean,
That's what it's
I
fun.
know it, guys.
Exactly.
I just want you to say it.
Yeah.
Doc, you mentioned that we have, that's my last question before we go more into the presentation and everything, but you mentioned we have a workshop at the headquarters to build foils. Why did we do that?
To be faster in the development and to be able to test more shapes. So nowadays, with the gear that we have, is between the time where we have a meeting discussing about the shapes, then Charles is like within the day or the next 2 days, he will work on the 3D geometry. And then after that, we can make a mold that is roughly about a day and a half. And then we can laminate, so make the foil. So within roughly a week or a little bit more, we can have a foil that goes into the water. So with this, then we can, have complete control on the prototype phase and then iterate very, very easily and very fast.
So I think it changed after the first Eagle. I mean, the Eagle X, no, the skate?
No, the Eagle.
Eagle X.
No, even the Eagle. So
Eagle
it's
is probably
basically when I came aboard.
It was already the Eagle.
When I came, it was already there was some prototyping done.
Yeah.
But it was very long because you had to
Was not in-house.
organize the mold for someone else.
Yeah.
Then it will basically take 3 weeks to come. And then there was another guy that was that was not internal of F1, that was doing the lamination or the construction. And it was also
Was quite long.
taking about 3 weeks. You had a prototype in about a month and a half.
So same as a factory. The thing is, I'm asking this question because making a prototype, making a mold at the factory is roughly 2 months, and then they need to do the sample and then send it. So it takes about 2 months and a half, sometimes more, to get one sample from the factory. And we used to work like that before the Eagle, but it was just not possible. You cannot have just that few samples per year because you cannot, push the envelope and innovate with this. And being able to have a foil completely designed and built within 7 days to 10 days is a whole different story. So, when a competitor can do one sample every 2 months and a half, we can do 8 to 10 different samples. Yeah. So we're going a lot faster.
And it's even more important nowadays because we are at the tip of the learning curve. So before, the gap was so big, then the small improvement that you make on a foil, it will make a huge difference. You could end up with, 3 or 4 prototypes, and you were happy with, launching the next year. But then now with, the competition being around also, but also we are at the tip of the learning curve. So all the parameters are very sensitive and they have small effects, but when they are combined, we can achieve something. So we need to actually make more prototypes now than we used to.
Yeah, for sure. I think we can all agree that it's much more difficult to make a better foil now than
exactly.
a few years ago.
It was so easy.
Much more work.
Yeah, absolutely.
So we have 2 new foils. That's the whole collection. We have 2 new foils this year. We have the Momentum and the Skate V2. Skate V2. Sorry. We are going to talk in details about this product. The guys are going to talk about it, but brief history on both and brief intro on both. The Momentum, 16.5 aspect ratio. I think this is the main features that you are all looking at, and very innovative stuff. Took us a year to make it when...
Only a year?
A bit more, maybe. I think it's a bit more. I don't know. Basically, last... the Molokai race in Hawaii from 2 years ago.
2023.
We were expecting a good result. We didn't get a good result. We were really upset. So Molokai for us is during the night. The day after we had a meeting and we decided that we really needed to win the next year because I don't want to be upset for 2 years in a row.
Yeah, I remember that debrief.
Yeah. So we decided that we were taking a year to build the foil that will win the Molokai the next year. So we started working on it. The guys will explain how we did it. It was the most complicated foil that we've ever done. And 16.5, I think it's one of the first foil on the market with such an aspect ratio. while still being controllable enough, stiff enough.
Usable by everyone.
So really interesting. You guys have tried it, most of you. The feedback is that for such a foil that looks scary, from you see it, it's very, very easy when you go on the water with it. The skates, so this one was really difficult, but we had learned a lot of stuff on structural design over the last few seasons, and we needed to improve the skates, and we kind of knew where we wanted to go. We took on the challenge to improve the skate a lot while not touching the shape. And so we have released a product that is the exact same in terms of shape, but only the construction, the structural design changed. And that was a challenge to achieve, but that was also a challenge for us to release it and explain it to the customer. You know, not having people say, guys, you're selling the same stuff, you just changed the graphics, come on. And feedback on it, I think we didn't have anyone saying that it's the same foil. Everybody really felt the difference. So that felt great. Yeah. And I think, Doc, you're going to explain more about how we made a difference in between the V1 and the V2.
Yeah. DSD stands for Dynamic Structural Design. So it's the name of the technology that we call that. What I do is, so as I explained before, I have a kind of a fixed geometry. And then after that, I'll play with the different constructions. So you have the fibers, you have different types of fibers. So you can have either e-glass, which has a very small, like a very low modulus. Then there's the standard carbon fiber, which pretty much everybody uses, which has a little bit more of a higher modulus. And then after that, there's what we call high modulus fibers. So that's what we made pretty much the whole range. So from the Eagle, the Skate, our HM mast as well is made with high modulus fibers. And then there's the ultra high modulus fibers that are even stiffer. And the problem with playing with this is there's lots of different parameters. And there's lots of opportunity for it to go wrong, so you need to be very careful. So the DSD is basically playing around with the different fibers. So I have a little, during my years in the industry, I've developed a little, let's say, a program that basically evaluates the stiffness of the foil, and you can basically build the stiffness pattern or the flex pattern of the foil. So if you, let's say, imagine that you bend your foil, you can calculate how much it will deflect and how it will deflect. So is it more on the tips or more towards the center, etc., etc. So the DSD is basically playing with the different fibers, so the different fiber stiffness and the orientation of it. So you can have fibers along the span that will basically stiffen the foil. And then what I call off-axis, so is either at plus or minus 45, plus or minus 30 degrees, 20 degrees. I can play with a lot of different orientation, a lot of different extents of the fibers. So either I make it to go on the full span, or either I stop at different points. And all of that make a flex pattern, or like a stiffness behavior, let's say. And so usually, as I explained before at the beginning of the presentation, when we order a mold, so a foil shape, then we can receive multiple constructions with all different flex pattern. And what I do is I give that to the R&D team. It's completely blind, so all they know is A, B, C, D to whatever letter it is. So there's what I call the revisions of the construction, so the different options in the constructions. And Raph come back from the water and says, well, I really like the B, for example, I really like the E, or what I want is a mix between the E and the A and stuff like that. So we discuss in length with what he likes, and we go from there and we iterate on that. It's really cool, and it's really important that is completely blind. Because with all the years of experience, he knows if you tell him what is going to do, what he's supposed to do, it will come and say, okay, well, we will have some first expectation before he goes in the water, rather than a little bias. So when it's completely blind, then I know for sure that it's unbiased, and we can really, you can really focus on the feelings and find the best construction. And the funny thing is not always the stiffest that wins, and it's usually not the stiffest that wins. It's always a mix between flex and stiffness, and it depends on the different disciplines. So skate will have requirements that are different from a momentum, from an Eagle X, and that's what's fun. Yeah,
depends on the size too, I think.
So
we have a different layup. Depends on the size inside of the same range.
Exactly. We have a size reference. So let's say, for example, a skate, it's a 850. Then we developed the first kind of a big chunk of different construction. We developed that on that size because we know it by heart. And then after that, we select a few construction and we make the other sizes. For example, on the skate V2, the 550, the 650 have a different layup from the 750, have a different layup from the 850, etc., etc. So it's very tricky for the factory and the communication between us two as well, because I need to have 100% confidence on what they're doing. So I usually go there and we do some random checks as well, be sure that it's what we've designed. But yeah, it's different from all the sizes.
We decide to spend time on that subject because we realized that on the water, winging or surfing, we had huge difference between two same foil just by changing the layup. So when I realized how it can be different, I said, okay, we need to work on that because this is where we can win the most. It's better to spend more time on the stiffness, flex, and twist than designing a new foil. So when we are on the water and we have A, B, C, D, usually we go me, Mika, Jules, Matt, 4 people, 4 same board, 4 same mast, and we all have a different letter on the foil, and we can swap on the water, and we can test the whole day and really check which one we prefer. We go upwind, we go downwind, we surf, we pump, we do all the different disciplines, and then we can decide which one is the best and start from that letter and try to improve it again, like you explained. I can give you a skate out of the mold with the wrong layup, and it can be such a bad foil. You can completely destroy your design by using the wrong layup.
Yeah. So we have made some pretty weird foil or pretty weird noodles.
And sometimes you think it's going to be the best, and it's totally wrong.
Doc, what you just said on the front wings is kind of similar to the mast, applies to the mast too.
So the DSD is really playing with the fibers, with the stiffness and the orientation, etc. And then we play with, as it's on the screen there, we have a mast that is bending more or less depending on what do I do with the fibers, and then same in torsion, so it's always playing with this.
Maybe we can talk more in detail about the two new products. We start by the skate, I think. I don't know. Yeah, skate. So with the skate, I mean, this is the most successful foil that we've ever had in the range, probably the most successful in the world. So people were really afraid when we said we were going to do a V2 because people love it and they were afraid that we kind of fuck it up. We were afraid too, to be honest. I would say there is one thing that was a flaw in the skate that we wanted to improve is that sometimes when you're carving hard or you're in a steep part of the wave or you're going really fast against choppy water in winging, you could feel overpowers. That gave you a bit pitch instability. And we really wanted to get rid of that and have the smoothest foil possible. So you can do your bottom turn or top turn on a wave and push as much as you want without hesitating. And we felt like after testing different shapes that the best way to achieve that smoother foil was to use the layup. Yeah, we've been doing prototypes of different shapes, but at the end, the best foil came out of the same mold with different layups. And so that's how we improved the skate. Anything to say about that, maybe?
I'm always the bad guy. because I am on the water. I come back and I come to those guys and say, it doesn't work. And finding what we should change on the skate was difficult, yeah. And we choose to go for more comfort and more control because it's the most important for the pro rider, but as well for our customer. And it was really amazing how much we could win by just changing the layup, like I said before. So the road was so straight and nice that it was the way to go. And days after days and size by size, I was really amazed by the result and how much you can cross the chop, go fast, go upwind, be overpower, go for a carve, and surf with the new layup compared to what we used to have on the V1.
When you think about it, I'm surprised because people really understand that we can improve the foil just by the construction. But people would, if we take a wing or a kite, for example, and we have a regular dark run over an Alula, it's kind of the same difference. You change the materials and the structure rather than the shape.
Yes.
You change a bit the shape, but so it's kind of the same thing. You know, we have to think about the skate like an improved version.
Exactly.
It's like the Alula compared to the skate people.
Yeah, or even, changing the panel orientation on the kite or on the wings. It's changing how the wing behaves.
Same thing.
Like you could keep the same profile, but just changing the panel size and panel orientation will...
This is what we have done with the sweep control panel.
Yeah.
We select the material, the stiffest where we need them, and we keep soft where we like to be soft.
Yeah.
Foil and mast. Maybe the stiffer mast is not the one we like the most.
Mm-hmm. Yeah, on mast is a bit more towards stiffness because there's so much feeling. Yeah, what you're doing is you're controlling, you're playing underneath. So
it's a linkage element.
Yeah, it's so you need to have a very stiff link so you can feel everything. But as you said, it's not the completely. The most high modulus usually, because if you go too stiff, then you will have kind of a bad feeling on your legs or stuff like that will basically pollute the other part of the feeling. So
it's got quite a big influence on the maneuverability. How the various parts are. It's also true for the connections and everything. So whenever you're changing a small detail, it always has a lot of implications in many aspects.
Yeah. This is why it's hard to design a good foil.
Getting harder and harder, yeah.
Yeah, and coming back from the Skate V1, which was already very good.
I hope it's
a greater challenge.
It's difficult for us to improve the skate, but I hope for our competitor it's even more difficult.
So what if we look for the like if the customer comes in a shop, I really like to have this question, and he says, I have a V1, what should I buy a V2? What would you say, like in terms of
the control comfort on the V2 is superior, so it's good for almost everyone. From beginner to pros, it changes your life. You are a better surfer, you go faster, you are more stable. It's funny because the first comment we got from the V2 is that, wow, it's stiff. And I was like, it's not stiff. I think most of the people translate control into it is stiff. But what they should say first is, I am stable, I have control. But they should not say it is stiff, because it's not stiff, in fact. We're not going to tell everything back.
It's just a control feeling that you get better.
Yeah. And you translate that into, they make it stiffer, they make it heavier, but this is rumors and legend. It's not heavier, it's not stiffer. In fact.
It's just more control. And one of the biggest assets that we have as well is the monoblock construction. It gives us a lot more control over, these parameters, like how much we want to play on the flex, everything. When you have a connection, when you have one more connection, for example, between the fuselage and the front wing, then, you just have that, and you have to deal with it, and you cannot, have an impact. I mean, you cannot leverage this as you want. So it's a really strong asset. this monoblok construction. It's also quite a rare opportunity to be able to bring a lot of control and comfort without altering any other parameters.
Yeah.
Because, like trying to do this with the shape, it's when you reach a certain level of performance, you will always lose, something. Because obviously, at least in terms of shape, usually, maybe 99% of the time, the performance is opposite to the stability and to the control. So
classic one, you get more glide, you lose some maneuverability.
Exactly, if you want more speed, and then you're gonna have if you go for a more high performance profile or envelope or things, and then you start to be on the edge of the other parameters, and so it was great that we could actually achieve such a big improvement through the construction.
Okay, guys, let's talk maybe about the other baby that we have in the range, the MOMENTUM. I told a little bit the history behind how the MOMENTUM came into the market. It was really designed at the beginning to be a race, SUP downwind race foil. So what you need in SUP downwind is a lot of glide, because you want to make sure that you don't put a lot of effort into pumping for 20 kilometers. So you need something that has really a lot of glide. And that was achieved mainly, but not only, with the very high aspect ratio. Actually, 16.5 is really extreme. And then you also need top speed and low end. This is really interesting, because we could see that the fastest rider on the downwind is not the one with the biggest top speed. It's the one with the biggest average speed. So you need to be able to have the top speed when those big bumps are coming. But when the smaller cross-shore bumps are coming too, you need to be able to kind of glide through it, go through it. So basically, you need a foil that always goes forward. And when you pump, that really has that going forward momentum. When you have some foils that don't have that, you can feel you are pumping, and the foil is getting you a lot of vertical lift. So we were looking at the opposite of that. We were pumping, it's going forward. So glide and average speed and low end.
Yep.
During the race, these guys have to paddle up on the flat, so they need low end. And they have to pump most of the time, especially at the Molokai. The last few kilometers are mainly on the flat. Mm-hmm. So they have to pump for a while, and they need a very good low end. The funny part is we really had these parameters in mind to do a race SUP downwind foil, but that's exactly what the customer is looking when winging or doing any sport on foil. They are looking for a good low end because they want to make sure that they can take off easily, even in lower wind. Mm. They are looking for a good glide because they don't really know how to read the bumps like Edo Tanas will be. Mm-hmm. And they are looking for good average speed because they want to go fast, but they also want to be cruising. So the MOMENTUM ended up being a good foil for everyone and a great foil for winging. So like halfway through the development, we were like, hey, we're not doing a Formula One here. We're doing a foil that can compete in Formula One, but can be used by anyone pretty much. And then because obviously we really like to carve at F1, we try to put as much maneuverability in this foil as possible. So we ended up with a foil that can race, but is also quite fun for the regular customer to carve around. So we have a foil that is, kind of a versatile Formula One, if we can call it that way.
But we have to realize that when our top rider need to take off with a paddle, we have to take care of this for the MOMENTUM, but it is good for our customer because they need to take off as well, even if they don't do it with a paddle, they're doing it with a wing or a para wing. So the downwind competition program is really complete. It's like what our customer needs and everyone needs. Getting on a plane, gliding. Maybe, Charles, you should explain. We are talking a lot about aspect ratio in the foil world, but the more the word finesse, nobody speak about it. But why we went for the biggest aspect ratio we could get, it's for the finesse.
Yeah, it's the drop rate, basically. Yeah, how many meters are you going down for every meter that you're going forward? So I think this is what most people relate to the glide, and like how much can you go forward with an initial, impulse.
With 85 centimeter.
Exactly. So when we're downwinding, the foils are mostly working, except when you have a big bump or a big wave, but you're using a lot the average range and the low range. So in these conditions, basically, this is the moment where the foil is creating stronger vortices at the tips. And it's creating what we call induced drag. And having a higher aspect ratio is improving a lot in that respect. It's reducing the tip vortices and reducing that part of the drag. So the higher aspect ratio you can be, the more performance you can extract in that zone of the performance range. And that's why it's working especially well for downwinding. And what we had before is, the Eagles and Eagle X, they were quite fast, but the feedback from the riders were that, when the conditions at some point were a little bit smaller, then they were starting to be slower in their lower end than other foils. And so we needed to gain that performance in the low end. They were still able to fly, obviously, but they were a little bit slower in that zone. So by increasing the aspect ratio, we were able to make all these gains into the low end and get the performance envelope from the high end all the way to the low end.
What about the winglets? Because we have some questions about that.
Well, the winglets, it's just another way to increase the aspect ratio even more. Basically, having these little winglets is reducing further the tip vortices. So basically, the flow around the wing will be just like it would be with an even higher aspect ratio wing. We make them small because we don't want to scare anyone, but it's quite efficient. And also, it's also guiding you, in terms of yaw. So when you're pumping, it's a little bit more efficient as well. All in all, its performance gains quite clear.
It's important to explain that because of all those high aspect ratio and positive side on glide and power, you can reduce a lot the area. With the momentum, you are going smaller.
Yep.
And now our top rider, they are using 5.16, 6.16 and they can paddle up and do races. And if you have a smaller foil, you go faster. So at the end, it's a circle you go,
Yep.
You have more glide, more power, more low end, then you can use a smaller foil, and then you go faster. So if you choose a momentum in the range, you have to go smaller than the Eagle X.
Definitely.
One size smaller.
Yeah.
At least, yeah.
To take advantage of everything.
You guys want to talk about how the momentum was built with these things that we see on screen, the CFD?
Yep, because for the Eagle X, we already had to, the ideal shape couldn't work. It was too thin, because as you extend the span, then obviously you increase the bending moment. And so the wing is going to bend more. So if you just increase the span and if you don't change the thickness, then you're just going to have a noodle, as Doc said previously. So with the Eagle X, we already had to increase the thickness more than would have it just for the hydrodynamics requirements. And so obviously as we decided to go for this race-winning foil, we were wondering, how high can we go in terms of aspect ratio, and how can we match this structurally? And so, because we're going to make some gains by increasing the aspect ratio, but we're also going to make some losses by increasing the thickness, because this is going to make more drag. So, in order to quantify this precisely, we made a campaign of simulations using CFD tools. We had quite a few runs, and we tested several, increasing progressively the span and increasing the stiffness to match accordingly, to keep the same ratio of thickness over span. And we could see the end results in terms of drag, is it a faster foil or is it a slower foil? And we could check this at several speeds. And in the end, we could actually see that increasing the aspect ratio and the thickness together, we would probably lose a few percents in the high range, but maybe 5. But we were going to gain 25 in the low range. So overall, we increased the performance envelope quite a lot. So we did this work before doing the first prototypes, just before starting to build. We wanted to check how how far we could go in terms of aspect ratio. And like at that time, the biggest aspect ratio we could see was 13, and we went to 16.5. So maybe we'll go for more later. I don't know. We'll see. But at that stage, this is already pretty good. And we've had to also use ultra high modulus carbon in them to keep the shape as it should be, and having it not to bend too much. It was probably just as much work, even maybe more work, to get the right layup for you.
Yeah, well, it's every time we have more complexity in our foil, and we increase the number of construction samples that we need to do. Here we are on the Momentum, we will maybe like 10 or 12 different construction types, going from something that we had already calculated based on our experience. So we knew where to go first, and even so, we had to make multiple iterations. So.
It's definitely the most complex foil we've built so far. Design.
Oh yes.
It's we didn't decide it's gonna be a 16 aspect ratio. The CFD tell it to us. The maximum you can do is 16.5.
Yeah.
That's important to say that the CFD decide.
Yeah, well, we never know. Maybe we'll find other tricks later.
Today with the material we have, we cannot go more than 16.5 for sure.
Yeah.
If we have new material, maybe one day we can try to go for more aspect ratio.
It's always when you venture into new territory, you don't exactly know where you're gonna land. You also like, okay, we're making this new foil, which is we're increasing the aspect ratio so much, but we're not. At that stage, it's difficult to know which size is actually going to be used by a given rider, because obviously you're going to drop in size, but it's not always easy to know how much.
No, yeah.
So you don't want a foil which is 1 meter span as well. So you need to learn as well progressively and step by step. It was already quite a bold move when we did it.
Oh yeah.
Because I mean, it's easy. You could say, okay, we're going to make aspect ratio 18 and just build this massive thing. But if you can't turn it, if it ends up too draggy, it's not a winning combination. So
I've tried many at the beginning of the new extreme aspect ratio trend. We've tried many 11, 12, 13, 14 aspect ratio from other brands, and I mean, yeah, you had a bit of glide, a bit better, but compared to classic foils. But the control was horrible. The maneuverability was shit. So it's always like, yeah, it's okay. We could do a 20 aspect ratio, it's okay. But if it's shit when you're riding it, then it's useless. So
and as you said before, it's always a compromise with maneuverability as well. Like even on a Dornan race, you don't go, completely straight. You still need to read bumps and then make some turns from time to time. So if you can't get it turning, then you
get into too niche.
Absolutely.
Customer base. Yeah. Also, people are already afraid of this one. So.
So well, we decided to use the same outline as the Relax on that one to get that nice maneuverable feel. And then what's making it work and what's making it a good foil is the performance envelope for sure.
That's it from us for today. We hope you enjoyed the episode, and thanks for tuning in. Don't forget to subscribe so you don't miss the next one, where we'll dive into wings, K-wings and pocket wings. If you have any questions, feel free to drop them in the comments or send us a DM on social. We always take time to respond.